Hey everyone! Today, we're going to dive into one of the best parts of being a developer, that feeling when you take a messy, clunky piece of code and step by step, turn it into something clean, elegant, and just right. To do that, we're going to walk through an amazing case study from Robert C. Martin's classic, Clean Code, and see exactly how this transformation happens in the real world. But first, let's talk about a problem we all know way too well: the creeping, silent cost of a mess. And I'm not just talking about code that's hard to look at. I'm talking about a hidden tax that slowly but surely grinds productivity to a halt. This graph, man, it tells a painful but very familiar story, doesn't it? When a project kicks off, productivity is through the roof. But as the codebase gets messier, every little change, every new feature, it just gets harder and harder. Before you know it, the team's speed is plummeting towards zero. We've all been there, right? Wading through a swamp of tangled code just to make a simple one-line fix. It's frustrating. So, how do we end up in this mess? Well, it usually starts with that little white lie we tell ourselves. I'll just get this working to hit the deadline and I'll clean it up later. But here's the hard truth, summed up by LeBlanc's law. Later equals never. That day you promised you'd go back and refactor, it almost never comes. And this kicks off a vicious cycle, the core struggle for any professional developer. We feel the pressure to go fast, so we cut corners, we make a mess. But that very mess is what slows everything down, causing us to miss the next deadline and the one after that. The book makes a powerful point here. The only way to truly go fast is to stay clean. So if we know that first drafts are almost always going to be a little messy, how do we ever get to clean code? Well, it's not some magic trick. It's a discipline. It's the philosophy of refinement. This right here, this is the key. Nobody, and I mean nobody, writes perfect, clean code on the first try. It's just not how it works. It's a process. You have to start with something that works, even if it's ugly, and then you apply your skill, your craft, to clean it up. And this process has a name: successive refinement. Think of yourself not just as a coder, but as a craftsperson. You're like a sculptor, starting with a rough block of stone, chipping away a little at a time, or a writer going over their first draft again and again. You make tons of small, continuous improvements until something truly elegant starts to emerge. Okay, enough theory. Let's get our hands dirty. We're going to dive deep into the book's case study and follow step by step as it refactors a seemingly simple tool, a command line argument parser. So the goal is pretty straightforward. We need a little utility that can take a schema and a list of arguments from the command line and then let you easily get the values for different types. Booleans, integers, and strings. Seems simple enough, right? And in the beginning, it actually worked. But then came the need to add strings, and then integers. With each addition, the code devolved into what the author so bluntly calls a festering pile. To add a new argument type, you had to go hunting through the code and make changes in 3 or 4 different places. It was fragile, confusing, and any change felt like you were playing Jenga with a very, very shaky tower. Now, the typical instinct here might be to just plow ahead, add the next feature, and make the mess even bigger. But this is where craftsmanship really takes over. Instead of pushing forward, the author stopped and began to refactor using 2 absolutely critical tools. First up, test-driven development. Think of this as your safety net. When you have a really solid suite of automated tests, you gain this incredible confidence. It lets you be brave. You can tear the code apart, move things around, and completely change the structure, all while knowing that as long as those tests are passing, you haven't broken anything. The second tool is the strategy: incrementalism. The secret to a big, successful refactoring isn't one giant, terrifying leap. No way. It's a series of dozens, even hundreds of tiny, safe steps. You get into a rhythm, make one small change, run the tests. They pass. Good. Make another tiny change. Run the tests again. This discipline ensures the code is never really broken for more than a few seconds at a time. So, with that safety net of tests and a strategy of taking tiny steps, what was the actual breakthrough? How did the code get from that tangled disaster to an elegant solution? The real knot at the center of this whole mess was this big, ugly block of if-else statements. You know the type. If it's a Boolean, do this. Else if it's a string, do that. Else if it's an integer, and on and on. This is a classic design flaw because every time you add a new type, you have to come back and make this chain even longer. So how do you get rid of it? The big aha moment was creating an abstraction, an interface called argument marshaller. Now, instead of having the main class know how to handle every single type, the responsibility was inverted. We'd have specialized classes, like a Boolean argument marshaller or a string argument marshaller, and each one would be an expert on how to parse itself. And this is the payoff. This slide says it all. On the left, you've got that rigid, ugly if-else chain that needs to know about every single type. And on the right, it's replaced by one single, beautiful, polymorphic line of code. The main program no longer cares what kind of argument it has. It just says, hey, whatever you are, set your value. And the specific object knows exactly what to do. That right there is the magic of good object-oriented design. So, what's the big takeaway from all this hard, disciplined work? Well, the result isn't just code that's prettier to look at. It's a system that is fundamentally transformed. It's more robust, it's easier to understand, and as we're about to see, it's dramatically easier to extend. And this right here illustrates the power of the new design perfectly. Let's say we want to add a totally new argument type, like a double for floating point numbers. Well, we don't have to touch that core parsing logic at all. You just create a new double argument marshaller class to handle the details. The change is totally isolated, it's simple, and it's safe. The system is now, as they say, open for extension but closed for modification. Ultimately, this whole case study comes down to a simple but incredibly powerful professional ethic, the Boy Scout rule. Just leave the code a little bit cleaner than you found it. You don't have to refactor the entire system in one go. Just improve one variable name. Break up one function that's a little too long. That's it. That's the whole game. So the next time you're looking at your own codebase, remember this story. You don't need some massive, risky redesign to make things better. It all starts with the discipline to make one small improvement and then another. So my question to you is, what's one small mess in your code you can clean up today? Thanks for joining this explainer.